Welcome back everybody. This is our 12th class in JEE mains previous year questions for chapter electrostatic potential and capacitance. This is a subtopic of a class 12 chapter, that is electrostatics. And before this video we have completed 11 videos in this series, and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for neet previous years, so you can go to our channel and find those videos also. And if you find those videos useful, then you can press the like button, share them, and subscribe to our channel. Also, if you want to support us, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. With your donation in future, we will be able to keep on making these videos on regular basis. So with this, let's start today's video. And in our previous video, I think we have completed up to question number something 93, 94. And hopefully this is going to be last video in this series. So here it is. So we have completed up to 93. And today we are going with question number 94, starting with 94. So let me adjust the thickness and screen also for writing. So here the figure shows an experimental plot discharging of a capacitor in a RC circuit. So capacitor is getting discharged. Now time constant of this circuit lies between. So we have to find the time constant of this circuit. Now we know that when there is a charging of a capacitor, the charging of capacitor is given by equation that Q is equal to Q at any time t is Q node 1 minus E minus T by RC. This is the charging equation, I think. And the discharging equation is Q is equal to Q node e raised to power minus T by RC. This is the discharging equation. Now, in this graph, we have potential difference and times in seconds. So what we do, we take value of potential and time from this graph, and we'll also use this equation to put those two values into single equation. Let me show how it can be done. We know that Q is equal to CV. So here we can put value of Q is equal to CV, and Q node will be equal to CV node, because while charging and discharging, capacitance of a capacitor will not change until unless we put an dielectric slab inside it. So only then there is a chance that its capacitance will change. Unless its capacitance will not change, so only potential will be changing across it, and that will be equal to maximum potential that is possible, that is V node, or that is a potential we applied, into e raised to power minus T by RC. So C get cancelled, and from this we get V is equal to V node e raised to power minus T by RC. So from this equation in Q, we transformed it into equation in V. Now considering any 2 points, suppose here T is 200. So when T is 200, the corresponding potential V is 5, and also we can take some other value that when T is 300, the potential is 25. Sorry, not 25. Okay, we will not take this value because here potential is 0. So we will take T is 250. Note, we can also take 250. We have to take some value where we have good representation from the graph. So like on 200 we have absolute value of potential, that is 5. On 250 we don't have, on 150 we don't have, on 100 we don't have, on 50 we also don't have. So first we will try only with this value, and we will try to solve only using these equations, these values. So V is 5. Now V node is the maximum value of potential that is possible, and that is equal to 25, and is equal to e raised to power minus, here t is equal to 200, and divided by RC, because we have to find the time constant, and RC is also known as time constant. So this will be 1 by 5 is equal to e raised to power minus 200 by tau, and we can transform it into like ln 5 is equal to 200 by tau, and tau will be, or tau, 200 by ln 5. Now 200 by ln 5 is equal to, that is equal to 1.609. Now 200 divided by 1.609 is equal to 124.3, and so our answer lies between option D, 100 second and 150 second, because it is asked that tau times constant lies between, so it lies between 100 second to 150 seconds. Let's move to next question. So a capacitor of an oscillatory circuit is enclosed in a container. The container is evacuated. The resonance frequency is 10 kilohertz. When container is filled with gas, resonance frequency changes by 50 hertz. So here it changes by 50 hertz. That is important. It does not become 50 hertz. It only changes by 50 hertz. The dielectric constant of the gas is, so we have to find out the dielectric constant of the gas. So we know that resonance frequency, or frequency of oscillation for a RC circuit, is proportional to 1 by under root RC, or we can simply say that even if we ignore R, that frequency is proportional to under root C. So F node is proportional to our original capacitance, and when we filled it with some gas, then the capacitance changes. Why? Because gas acts as a dielectric. So our new frequency becomes proportional to 1 by under root Kc, because capacitance changes to from C to Kc. And from this, as we know that gas will have some positive dielectric constant greater than 1, so this will effectively increase the capacitance, so frequency should decrease. Here it is mentioned that it changes by 50, so it is not mentioned that that it increases by 50 or decreases by 50. But from this relationship we can devise that the frequency will decrease by 50. So our initial frequency is 10 kilohertz, or 10,000 hertz, is proportional to 1 by under root C, and final frequency, which is reduced by 50, so that will be 9950, is proportional to under root Kc. Now dividing both of these, 10,000 by 9950 is equal to 1 by under root C and 1 by under root Kc. So this will give us, because this is 1000 by 995, so this will be approximately 1, and this side will give us under root K. So K will be square of 1000 by 9995. So when you solve this, our final answer will be option C, 1.01. Moving to next question. It is not possible to make a sphere of capacity 1 farad using a conductor material. It is possible for Earth as its radius is 6.4 into 10 raised to power 6 kilometer. Now in this question, both mention objects means in statement 1 it is mentioned as a sphere, so we have given a sphere, and in statement 2 Earth, when we calculate the capacitance of Earth, it will also considered as a sphere, and the capacitance of a sphere is given by 4 pi epsilon naught r. This is the capacitance of a sphere. So it is given that capacity is 1 farad. So 1 farad should be equal to 4 pi epsilon naught r, and from this r is equal to 1 by 4 pi epsilon naught, and we know the value of 4 pi epsilon naught, 1 by 4 pi epsilon naught, that is 9 into 10 raised to power 9, and it is radius, so 9 into 10 raised to power 9 meter. So for a spherical capacitor to have a capacitance of 1 farad, its radius must be equal to or larger than 9 into 10 raised to power 9 meter, and radius of Earth is also mentioned in second statement, that is 6.4 into 10 raised to power 6, which is 3 order smaller, means 1000 times smaller as compared to the radius of the hypothetical sphere, which has 1 farad capacitance. So statement 2 is wrong. By this by comparing both of these, we can conclude that statement 2 is false. Now going to statement 1. Now considering the practical scenario, when we live on object on Earth which has radius of this magnitude, we cannot create an object of radius of this magnitude on our Earth. So hence statement 2 will also be false. So both are false, and even considering that here it is mentioned that we have to create a sphere using conducting material, so even that will not be possible. So both statements are false here, and I think here both false are not mentioned. So if practical situation is not involved, if we are not considering practical scenario, then statement 1 can be possible, that in a hypothetical world we can create a sphere of this bigger radius. So in that scenario 1 will be true, but and 2 will be false. So option D in this scenario will be the right answer, but considering practical scenario both are wrong. Now next question. A series combination of N1 capacitor, each of capacity C1 is charged by a source of potential difference 4 volts, when another parallel combination of N2 capacitors, each of capacity C2 charged by a source of potential difference V, it has the same total energy stored in as the first combination has. The value of C2 in terms of C1 then. So we have to compare C2 and C1. So first, here it is mentioned a series combination of N1 capacitors. So we have N1 capacitors. Suppose this is second, a third, and up to we have N1 capacitors. Each of capacity C1. So capacity of each is C1. Now when we have N1 capacitors in series, each of capacity C1, then our final capacitance, we suppose our final capacitance is, that is CS. Suppose final capacitance is CS. So 1 by CS should be equal to 1 by C1, 1 by C2. Oh sorry, again all values are C1. So 1 up to 1 by C1, and these will be, we can say, N1 terms. These total will be N1 terms, and when we will add them, we will get N1 by C1, or CS is equal to C1 by N1. So this Cs is equal to C1 by N1. Now this combination is charged by source of potential difference 4 volt. So when we charge it by 4 volt, and here we have to compare total energy, so its energy will be, so US will be half Cs, that is C1 by N1, into 4 volt, so 4 square, that is 16. So it will become 8 C1 by N1. Now going to second scenario, when we have another parallel combination of N2 capacitors. So we have in parallel N2 capacitors. So suppose this is first, this is second, third, and up to N2 capacitor. So this is N2th capacitor, and each capacity is C2. Capacity of each capacitor is C2, C2, C2. Now all of these are in parallel, so we can represent them by a single capacitor, suppose Cp, and Cp will be, because there are total N2 capacitors and they are in parallel, so they will be simply added, so N times N2 times into C2. This will be the final capacitance, and charged by a source of potential difference V. Now this Cp is charged by potential difference of V, so here total energy Up will be half Cp, that is N2 C2 into V square. Now this Up is equal to Us, so we have to find C1 and C2 in terms, we have to find C2 in terms of C1. So if when we compare both of these, so half N2 C2 V square is equal to 8 C1 by N1, and actually we will also need value of V, only that will be solvable. Let me check if there is some values missing. Okay, there is no values missing. It is not 4 volt, it's 4V, and it is V. So this is 4 times of this potential. So here when we made this calculation, so we have to include 16 V square. So this will be 8 C1 V square by N1, and this will resolve the problem, and here we will have additional V square term. So V square get cancelled, and we have to find C2. So C2 will be 8 into 2 16 into C1 by N1 N2, and we can see option D matches with our answer. Moving to next question. So two circuits A and B have charged capacitors of capacitance C, 2C, 3C with open switches. Charges on each of the capacitor are shown as in the figure. On closing the switches, what will happen? So here we have 3C capacitor with 2Q charge. Here we have 2Q capacitor with 2C charge. And okay, so we have to, I think, find L2R. Okay, so we have to find that what will be the direction of the charge flowing in each of the circuit. Now, as we can see from both of the figures, that both of the capacitors in each circuit has some charge and has their some own capacitance, and we have to find the direction of the charge flowing, or we can say we can find the direction of the current. Direction of the current will be same as the will be opposite at the direction of the charge. So what we do, let's first find out that which capacitor has the higher potential and which has a lower potential. So first we will be solving for the circuit A, which we will be solving. So for circuit A, we know that Q is equal to CV, and from this potential is given by Q by C. So for this capacitor, we can say we name it as capacitor A and we name it capacitor B. This is capacitor C, so not C because C is already used. So this is capacitor D and this is capacitor E. So for capacitor A, potential is given by 2Q by 3C, and for capacitor B, potential is given by Q by C. Now we can easily see that potential at point B or capacitor B is greater than potential at capacitor A. Now considering that top plates are positively charged and bottom plates are negatively charged, so here this B capacitor has a higher charge or higher potential as compared to this A capacitor. So this is, if this is positive plate, so our current should flow something like this. Direction of flow of current should be something like this. So this is the direction of flow of current. And now uh, as here it is not mentioned that what charges we are talking about, but normally when there is a electric current, then we only talks about electrons, and flow of electron is reverse that that of current of normal current is, so flow is reverse of that with of electrons. Means if current is flowing from left to right, then electrons should be flowing from right to left. So for first circuit A, our charges should flow from R to L, and here we have only one option, that is option C, that matches with this criteria. Now also using same criteria here in the circuit B, potential at capacitor D at this capacitor will be 2Q by 2Q by 2C, so that is Q by C, and potential at capacitor E is equal to Q by 2C. So we can easily see that potential at capacitor D is on higher side. So if it is on higher side, and considering defaults that top plate is positively charged and bottom plate is negatively charged, so our current should flow something like this, because this is on higher potential. So here direction of current is from R to L, and flow of charge will be reverse, flow of electron will be in opposite direction. So flow of electron will be from L to R. So L to R, that is option C, will be the right answer. Now going to next question. Let's see with the capacitance of a capacitor discharging through resistance R. Suppose T1 is the time taken by energy stored in the capacitor to reduce half of its initial value, and T2 is the time taken for the charge to reduce to 1/4 of initial value. Then the ratio of both of these. So we have to find the ratio of both of these. So again, first we have to talk about energy. So for energy we have two relations, that is half CV square and also Q square by 2C. Now as capacitor is discharging, so its potential is also getting changed and its charge is also getting changed, and value of capacitance is fixed. So in first part, energy is reduced to half, but in second part, charge is reduced to 1/4. So in first part we have to solve for energy, and in second part we have to solve for the charge. So while solving for energy, we'll take equation that includes charge. So from this we know that energy is proportional to square of charge, and while discharging we know that how charge varies for a capacitor, that is given by Q is equal to Q naught e raised to power minus t, where t is the time, divided by time constant, that is tau, or tau is equal to RC. So From this, E is proportional to Q square and Q is proportional to Q node e raised to power minus t by t. So from this we can say that E will be equal to that maximum energy, because energy reduces to half, so E node, that maximum energy should be proportional to maximum charge or Q node square. And when energy reduces to half, so when energy reduces to E node by 2, then it will be proportional to some value of charge that we will calculate. Now if we divide both of these equations, what we will get? We will get E node by 2, so 2 will go on top, is equal to Q node square by Q square. So E node get cancelled and square taking root of both of sides, so root 2 is equal to Q node by Q, and reversing both of these, so 1 by root 2 is equal to Q by Q node, and now we know that Q is equal to this value, so Q by Q node will be, from this, 1 by root 2 is equal to e raised to power minus t, and time here is, for energy to reduce half, time is given as t1, so t1 by tau. So this is our first relation. And for our second relation, charge reduces to 1/4 and that time is t2. So charge reduces to 1/4, so Q is equal to Q node by 4 is equal to Q node e raised to power, now time is given as t2, so minus t2 by tau. Q node get cancelled, and from this 1 by 4 is equal to e raised to power minus t2 by tau. Now what we can do, we can take ln of both of sides, both of these. So for this, for this equation, we will get ln root 2 is equal to t1 by tau, and for this equation we will get ln of 4 is equal to t2 by tau, and again we can divide both of these equations, and when we divide both of these we will get ln by root 2 divided by ln of 4 is equal to t1 by t2. Now we know property of ln, that the powers we can adjust in case of ln. So this is ln 2 raised to power half, and this will be ln 2 raised to power 2. So this is t1 by t2, and both of these power will come outside. So half ln 2 divided by 2 ln 2 is equal to t1 by t2. ln 2 get cancelled from both sides, and from this t1 by t2 is equal to 1 by 4. So this is the ratio which we finally gets, and here it is, option C will be the right answer. Moving to next question. Let's adjust it slightly. So a parallel plate capacitor with air between the plate has capacitance 9 picofarad. The separation between its plates is d. The space between the plates is now filled with two dielectrics. One of the dielectric has dielectric constant K is equal to 3, thickness d by 3, while the other has dielectric constant K2 is equal to 6, thickness 2d by 3. Capacitance of the capacitor is now. So we have to find the final capacitance. Now it is mentioned that initially capacitor was something like this, of thickness d, and now we filled d by 3 part of this with K1 is equal to 3 and remaining part by K2 is equal to 6. So this will be like two capacitor in series. This is first capacitor This is second capacitor with K is equal to 3 first, and with K is equal to 6 with second capacitor. So, and also uh, original capacitance is mentioned as 9 picofarad. So C node is equal to 9 picofarad is equal to epsilon node A by D. Now going to first capacitor, or we can say it is C1 and this is C2. So for C1 we will have K epsilon node. It has the same area but only thickness is D by 3. So this will be 3 times K epsilon node A by D, and 3 times K is 3 and epsilon node A by D is equal to 9. So this will become into 9. So final capacitance will be 81 picofarad. For now C2 we will again have K2. So this was K1, this is K2, epsilon node A, and here thickness is 2D by 3. So 2D by 3. So 3 will go on the top. K2 is 6 into epsilon node A by D, and here it is 2. So 3 into 3, 9, and again this is 9. So this will be 81 picofarad. Now both of these capacitors, C1 of is 81, C2 is 81, and both are in series. So their parallel combination will be 81 by 2 picofarad. So option C will be the final answer. Moving to next question. Parallel plate condenser or capacitor with dielectric constant K between the plate has a capacity C and it is charged to potential V. Dielectric slab is slowly removed from the capacitor and plate and then reinserted. The net work done by the system in this process will be. So in this question, first we have to find some particular value that remains constant throughout this whole process. That first we remove the slab and then we insert it back. Then we have to find a particular value which will remain constant throughout this process. So as it is charged and then disconnected from the battery, because it is never mentioned that it is kept on potential kept to connected to battery. It is only mentioned that it has a dielectric constant K, potential capacity C, and charged to a potential V volt. It is charged and now disconnected. So if it is charged, so Q will be constant. So charge on this capacitor throughout the whole process will remain constant. So when slab is inside the capacitor, so its energy we can say is initial energy, and it will be given by Q square by 2kc, because charge here remains constant, so it will, and only capacitance will change. Now when we remove the slab, so again charge will stay the constant, so it will be U square by 2c, and this is the final one. Now we have reinserted the slab, so again charge will remain the constant because charge cannot change because it is not connected to any battery, so only capacitance will change. So at this time when we remove the dielectric, the denominator is decreased, and when decreased, so final energy was increased. Now when we reinserted the slab, denominator again increases, and again UF2 becomes equal to initial energy. And now if we find out the difference between both of these, it is equal to 0. So option A will be the right answer. Moving to next question. Parallel plate capacitor made of stacking an equally spaced plate connected alternatively. If the capacitance between two adjacent plate is C, then the resultant capacitance, we have to find out that what will be the resultant capacitance. So we have set up something like this, that we have alternate plates connected. So an equally spaced plate alternatively. Wait a minute. So our diagram will look something like this, that we have n capacitors which are alternatively connected. And let me make this connection again. So when they are alternatively connected, so this connection is behave like a parallel connection. And if we are given n capacitors, so this behave like say n minus 1 capacitors in parallel. So if we have n minus 1 capacitors of capacitance C in parallel, so their final capacitance will be n minus 1 times of C. So option B will be the right answer. Now next question. Fully charged capacitor has a capacitance C. It is discharged through a small coil of resistance wire embedded thermally insulated block of specific heat capacity S, mass M, temperature of the block raised by delta T, potential difference V across the capacitance is. So it is simply mentioned that when this capacitor is discharged, so due to its discharge there is some current flowing, and due to that current, that thermally insulated block temperature is raised by temperature delta T. So if temperature of some body of specific heat capacity S of mass M and is raised by temperature delta T, so it has absorbed energy or Q that is equal to ms delta T, and that energy is supplied by the capacitor which it was previously stored. So half CV square is equal to ms delta T, and now comparing these, V will be 2ms delta T by C under root. So 2ms delta T, option C will be the right answer. Moving to next question. A sheet of aluminum foil of negligible thickness is introduced between plates of the capacitor. The capacitance of the capacitor. Now it is mentioned that aluminum is introduced, and we know that aluminum is a conductor, and for conductor our final capacitance, if conductor of thickness T is introduced between the plates, so our final capacitance will be something like this, and we can write it epsilon node A D 1 minus T by T. And as it is mentioned that thickness is negligible, means this T is very small compared to D, so this term will reduce to 0, and our final capacitance will be again equal to the original one, so it will almost remains the unchanged. So option B will be the right answer. Now work done on placing a charge, value of charge is given on a condenser of capacity 100 microfarad is. So we have to find the work done. C is 100 into 10 raised to power minus 6. Q is given 8 into 10 raised to power minus 80 coulomb. So work done will be equal to the energy of this charge in the capacitor, and energy in form of charge is given by Q square by 2C. So it will be 8 into 10 raised to power minus 36 power by 2 into 100 into 10 raised to power minus 6, so that we can write it 10 raised to power minus 4. So 432 into 10 raised to power minus 32. Option D will be the right answer. Now next question. N capacitor in parallel connected to V volt source, energy stored. Now capacitors are in parallel, so their final capacitance will be NC, and total energy stored will be half capacitance into potential square, so half NCV square, half NCV square, option B. And the last question is capacitance of a spherical conductor with radius 1 meter. So that will be C is equal to 4 pi epsilon node R. So 9 into 10 raised to power 9 into 1. I think, oh sorry, 1 by 9 into 10 raised to power 9 into 1. So this will be the order of 1 by 9 is equal to 0.11 into 10 raised to power minus 9. So 1.1 into 10 raised to power minus 10. That is option A. Hence option A will be the right. And with this, this whole chapter's previous year questions up to year 2020, I think, is finished. Hopefully these will be helpful to you somehow while your preparations. Again, if you have any doubts, comments or suggestions, you can put them in the comment section. And if you like video, then share it, subscribe to our channel. And also, if like to support us, then you can donate with whatever amount you want by scanning this QR code. And we will meet in next video with new chapter.